All right, welcome back, you guys. First week of real lecture pass. We got more stuff we can talk about in this class. This will be like day 3 of lecture content. And we're going to hit on the topics that we were touching on Tuesday, which I think for you guys is going to mean we're going to hit hard on the rules for exponents, because this is like really one of the biggest things that comes up in the class, and students fuck this up a lot. Let's just say it like it is. It's easy to fuck up. So as a reminder, we have, do I want to use A? Let's use X. X to the M times X to the N equals X to the M plus N. These are all things you've seen before. If you do want to write them down again, you can. And we're assuming X does not equal 0 for this stuff. Like the rules still apply, most of them, but when we have division, it doesn't. We could have X to the M, and then that all raised to the n power with parentheses. That is X to the M times N. Do you guys at home have a clear screen? Because it's like, oh, now it's clear. It wasn't clear for a while there. It was all choppy on my second screen. If we have two things multiplied together and raised to the m power, the m hits both of them. This kind of stacks. If we put these last two together, putting these last two together is something that a lot of students like choke on. So like, let's say we have x to the a and y to the b, and we raise that to the c power. This will be x to the a times c, and then y to the b times c. We've really done that here. This has this here, but a and b both equal 1 here. Then we have the division 1. We could have x over y to the n power. And this is x to the n power over y to the n power. Ooh. I need to open up the chat screen. Looks like someone said something. Okay, so it was a weird color for a little bit, okay? Hopefully it doesn't stay that way. So that was having x and y being different bases for the exponents. When we have x is the same base for the top and the bottom, like this, we have x in both spots. This leads to subtraction. A quick little example of this would be like x to the 4th over x cubed. I'm going to write it out and we'll see the cancellations. We see those go away together. Those, and each one gets replaced with a 1. And we're left with x to the first power, which is 4 minus 3. If I rewrite this one right here, x to the m minus n as x to the m plus negative n, like that, we can see that if we grab this rule from the very top and this rule, I pulled it from this rule. This is x to the m times x to the negative n. And it started as x to the m over x to the n. So this kind of shows the next rule, x to the negative n equals 1 over x to the n. Or x to the n equals 1 over x to the negative n. And one last rule. X to the 0 power is 1. Again, x does not equal 0. 0 to the 0 is something you'll look at in calculus. The hell did I do when I got home Wednesday night that I didn't upload the videos? Weird. So I'll leave these up while we give you guys some practice problems. Hello. Doing all right? Trying to figure out how I can get as much of this on the screen at the same time. Let's give you guys some practice problems to work on. We can start off light. X squared times x cubed times y squared. And that cube like that. We'll switch up that one. You like Butterfinger? Of course I like Butterfinger. Thank you. Oh, bear shit in the woods? Shit's anywhere damn well pleases. Thank you. Compliments to my daughters. Oh, thank you to your daughters then. Do they know they gave it up? Huh? They know they gave up the candy? They gave it to me. Oh. Not even asking what I do. Right? I pay everything. Right? They're just giving you back shit you bought. But it's the thought that counts. Yeah. You don't ever want to point that out. Thanks for giving me the shit I bought you. Put up some more. I got distracted by the Butterfingers, which is an easy thing to be distracted by, right? Which beat the product or let's beat this horse dead. Can you tell I'm making this shit up as I go?
So,
So, Jimmy,
do you have the course ID for Pearson?
it's in the syllabus
Oh,
on the very first page.
okay.
So you go down a little bit. It's also. If you click on the syllabus tab. You will see it right there, Jones 98470.
Okay. I just went straight from there to my math link and every time I go back. Okay. Thank you.
So there's like 6 million spots, maybe not 6, but not million, but maybe there might be 6 spots that have it. It's listed a lot of places. Oh, ooh, yeah. God damn, I haven't had one of those in a while. That's about good. I think it's better than Reese's. I like that crunchy component. How's everyone doing? Oh, Drew's at least still writing. His pen stopped, so I thought he was done, but nope. He was thinking. It's a good start. Thinking's always a great start. Okay. Yeah, you'll never see me put a number at the end. In mathematics, we always put the number first. Just like you didn't bring in Butterfingers 2, you brought in 2 Butterfingers, right?
Yeah.
We use the numbers first and everything. Still thinking, Drew?
Oh, yeah.
Okay,
Cogs are like burning.
I want you guys to. Guys to work on it, make sure you understand it. Are you guys all both done with A and B?
Are
Eric,
we doing
have you finished these?
Yeah.
Alright. Pedro and Xavier, you guys done with A and B? Let's make sure you guys, we're all on the same page. I'm hoping I see yes. So this, the cube only applies to that one, not those. So this part is gonna turn into x to the 2 plus 3, because we have multiplication. And this is gonna turn into y to the 2 times 3, which will give us x to the 5th power, y to the 6th power. On the next one, we gotta hit everything with the exponent. So anything that doesn't have an exponent, I'm gonna put a 1 on it. Because it's easy to forget. So this one right there, the 2 is gonna hit everything. I get 2 to the 1 times 2, x to the 2 times 2, y to the 3 times 2. And on this one, the 3 hits everything. 3 to the 1 times 3, x to the 4 times 3, y to the 1 times 3. And there's multiplication between them. Because they had parentheses next to each other. So 1 times 2 is 2, 2 squared is 4. 2 times 2 is 4, so we have x to the 4th power there. And on this one, we have y to the 6th power. And then on this one, we got 3, 1 times 3 is 3, 3 cubed is 27. X to the 4 times 3 is x to the 12th power. And y to the 1 times 3 is y to the 3rd power. If it helps you, rearrange these. Remember, multiplication is commutative, so we can change the order around. I can put the numbers together, I can put the x's together, and I can put the y's together. This step is skippable. It's just for those that like it sequential like that. 4 times 27, this is like 4 times 25 plus 2. So that's 100 plus 8 is 108. On the 4 and the 12, we add them together because they're side by side now. And the 6 and the 3, we add them together. So we end up with 108 x to the 16th power, y to the 9th power. A lot of work there, right?
Yeah.
You guys get it? Good. give you a couple more minutes for C and D. Since I dragged Drew out of his deep thoughts like a dick. Working away on his stuff. Fighting polynomials. That's Bet Drew's working on D.
Yeah, you'd be right.
You're gonna be mad as shit. I can already tell if you're working on it still, you're gonna be mad as shit.
Yeah, probably. Let's see.
But I'm gonna let you struggle for one more minute on this. I want you to like. The more you struggle on it, when you see it, it sticks better. It really does.
Yeah.
You're like, how the fuck did I miss that? Yeah, maybe fucking slapping yourself.
Was fighting on the homework yesterday. Pearson sends
Yeah, every once in a while they like to throw some doozies in there.
There's a couple of them though that didn't seem like they were right.
If it doesn't look right, do the ask my instructor with the problem. Like, don't go to the next problem. Just like stop. Like close the like, next question box. Just close it, and send ask my instructor and go. I don't think that. Like, I got a different answer. Clearly, you got a different answer because if you don't think theirs is right, I'm guessing you think yours is. So send it to me, and maybe even because if you send it to me, I'll see what you got, and I might be able to figure out what you did. And if I don't, I'll like message you and say, send me a pic of what you did.
There's something really simple. It just has to do with exponents because a negative base to a positive exponent is going to come out a positive product, right?
Depends. Only even exponents will make a negative base positive.
Even exponent.
We'll go over that in
Okay.
just a second. That's a great question.
That's what I meant actually, is a negative base to an even exponent.
We should always be
Should
positive,
always be positive, but
unless it's,
they told me I was wrong, that it was gonna come out to a negative.
was it in parentheses? Then the negative does not apply. No, I mean, the negative isn't getting the even exponent. I'll show you.
Okay, yeah.
So here we gotta add the exponents together, 2 plus 3 plus, I'll fill that one in, plus 1, plus 4, plus 5. And I got y to the 2 plus 1 plus 5. And z to the 1 plus 2. Let's see, I got 6, 6, and 9, 3 is 15. For x. Y is 8 and z is 3. For exponents. Now. I can, and I will. Do this the long way. In case you miss it, you'll do it the long way. And then I'll just point out the short way. We got to distribute this exponent to all of them. So x to the 2 times 0, y to the 3 times 0, z to the 4 times 0, w to the 5 times 0, v to the negative 5 times 0, u to the negative 4 times 0, t to the 3 times 0, and s to the 2 times 0. Which gives us what for every single exponent? No. 0. 0 for the exponent.
Oh, 0 for the exponent.
0, 0, 0, 0, 0, 0, 0, 0. Gives me 1 times 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 1. Which is 1. That's the long way. The short way is going, well, and it's a good thing to start doing because you're going to use it a lot. Sometimes it's good to substitute or like think of like the big picture. Like what if smiley face here was x squared y cubed z to the 4th, w to the 5th, v to the negative 5, u to the negative 4, t cubed s squared. This entire thing up here, with that in mind, becomes smiley face to the 0 power. Smiley face is just a new variable. And yes, I've used these in class on tests before. I've submitted it on my own test as a student. But anything to the 0 power is 1. So when you see 0 on the outside, you can literally just expedite all that shit and go 1. That's the shortcut. You guys ready for some more?
Sure.
I don't know. I see Ben's still gone. Let me let you finish writing and contemplating your thoughts. Good day, Luis. Why are you laughing? What was funny about that? Let me laugh. Let me laugh. You're gonna laugh. You laugh either way. I guess good day is not a normal greeting.
Yeah.
Good day, sir. Good day to you. All right, it looks like you guys are done writing. So let me throw a couple more at you. Let's just change some of this shit up. For x squared y cubed to the 2nd power times, let's go big or go home, right? I'll do another 4 here. And now we're gonna do x to the negative 3 and y to the negative 1. And we'll raise that to the negative 2. And maybe let's throw in like a 7 X to the negative 1, y squared. To the negative 1. Should be challenging even for our great math major back there. He's like, the good thing is I'm not in that class, so I don't have to do that shit. You might find it helpful to just focus on doing the coefficients first. And then doing all the x's at one time on another line. And then all the y's on the third line. And then multiplying your results together. I guess I did kind of make that kind of long, but it's just how I roll. It could be way harder than anything on the test, so if you can do this, you're doing good. over in like 2 minutes. Alright, you guys look like you guys feeling good. See what we got. So I'm gonna fill in all the missing exponents real quick, they're all ones. And if I look at the coefficients, the constant numbers. I've got 4 to the 1 times 2, 4 to the 1 times -2. And 7 to the 1 times -1. This is 4 squared times 4 to the -2 times 7 to the -1. There's a couple approaches you could do this. One is to do the 4, add the 2 exponents for the 4. And you're gonna get 4 to the 0, 7 to the -1. Which is 1 times 1 over 7 to the 1, which is 1/7. The other way you could finagle this is you could rewrite that -2 as an exponent on bottom like that. And you'll see that they cancel out that way. That's another way of canceling out the force. But either way, the number in front you should have is 1/7. Now we'll take a look at the x's. Got x to the 2 times 2, x to the -3 times -2, and x to the -1 times -1. This is x to the 4th power. -3 times -2 is +6. And -1 times -1 is +1. Now we add those exponents. And I get x to the 11th power. We'll need that in a second. You guys get to x to the 11th? Yeah. Take a look at the y's. We got 3 times 2, -1 times -2, and 2 times -1. Which is y to the 6th power times y to the 2nd power times y to the -2 power. Is y to the 6th power. So all said and done. We should have 1/7 x to the 11th y to the 6th power.
Can you explain again how you got 1/7?
Yeah. Uh. So we distribute the exponents to each of them. So 2 times 1 is, we got 4 to the 1 times 2 is 4 squared. -2 times 1, we end up with. So we got 1 times -2 is the exponent, so the exponent for that 4 is -2. And I've got 1 on the exponent for 7 and -1 outside. We multiply and we get -1. So. There's a couple, is the 4s are what's bothering you or the 7?
The 1/7. Like the 1/7x.
So the 4s didn't bother you, okay, so 7 to the -1, any exponent. Can be rewritten as like that with a negative, if we have negatives. Or we could have positive exponent there and put the negative on bottom. We started with 7 to the -1. And matching that format, it becomes 1/7 to the +1. And 7 to the +1 is 1 just 7.
Okay. I see now.
Good, alright. All good, guys? Okay. Take a few minute break. Well, 10-minute break. While we wait for the next class.